able to solve these circuits, we at least have to learn the basics between series and parallel circuits. So let's go ahead and do a quick little review. Starting off with series, I went ahead and drew a little circuit. We can see we have our power source of 12 volts. If we follow our circuit, we come across one resistor, our second resistor, and then we are back to our starting point. So as you can see, this is only one path for current to flow through. And I highlighted this little part right here to just emphasize that the components are always going to be connected end to end in series. And the same current that we all got coming in, it's going to be the same current coming out. And you can always learn a little bit more about the current by researching Kirchhoff's current law, KCL, because that is literally what's going to be embedded in your brain. Total current coming in is a total current coming out. The voltage divides across components. Now, I just drew a little basic circuit. I did not put the values for these two resistors, but of course, the 12 volts will go ahead and divide in between these two, depending also on their resistances. Now, since these connect end to end, if one component fails, the whole circuit stops working since it's only just one path for current to flow through. Moving on to parallel, I also drew a circuit right here. We have our power source, and then if we follow our circuit, we can go ahead and see that it reaches a point right here where it can go forwards or it can go downwards, and the current splits off and comes together back right here and then finishes off the circuit. Well, since I went ahead and explained that, we can already see that parallel is always going to have multiple paths for current to flow through. In series, we said that the components are connected end to end, but in parallel, I went ahead and highlighted these two little points right here because we can see at this point right here, the current will split off in two. It'll go downwards and then it'll go forwards, and it'll go through these two resistors separately, and then the current will join back up right here to finish off the circuit. In parallel, the voltage will be the same across each component, and you can go ahead and do a little bit more research on that by searching up Kirchhoff's voltage law. And as we already said, current divides between branches. We have one branch right here and then another branch right here. And parallel, I always like to think about it as like you're in a maze, right? You're starting off with your current, that being two people right here, but then you reach a point where there's two options you could go through. So each one of y'all decide to take a different path. Your friend goes over here, you go over here, and then boom, you meet back up at the same place. Now you're two friends again, and you're finishing off the same way you started. And lastly, for parallel, if one component fails, others can still work. So in a parallel circuit, each component is connected directly across the power supply. So each one has its own separate path for current to flow. So I want you to think of it like separate lanes on a highway. If one is closed, cars can still use the others. And that would be the same thing for parallel. If resistor 1 was blocked or wasn't working, then they could still use resistor 2 to go through.